Hello class, Professor Stewart. My name is Patrick Gear, coming to you from South Portland, Maine. I'm going to try and speed this up. My last recorded lecture presentation was about 20 minutes, so try and do this a little bit faster. Okay, so for my project I wanted to ask the question, will climate change impact well water quality in Manchester, Maine? So just to begin the problem, this is an image of what arsenic contamination or arsenic exposure may look like. According to the EPA, non-cancer effects of arsenic exposure can include thickening and discoloration of the skin, as you can see here, stomach pain, nausea, vomiting, diarrhea, numbness in the hands and feet, partial paralysis, and blindness. And arsenic has also been linked to cancer of the bladder, lungs, skin, kidney, nasal passages, liver, and prostate. So you can see that it is an issue. It's something that concerns public health, and we want to really get a grasp and a handle on exposure pathways. Here's a image from USGS. Here I am in the state, down here in South Portland. Okay, they do have, I guess, an issue with it. We're on city water here. We get our water from Sebago Lake, surface water. And this is the township I was really concerned with. It's Manchester Township. It's adjacent to Augusta, which is right here. It's in a high tourism is huge in this area of the lakes region. Great fishing and hunting, summer camps, etc. A lot of tourists come into this region. As you can see from this map, it has between 46 and I think this is 62% of the wells sampled were exceeding the EPA set standard of 10 parts per billion. From another study, here is a close-up of that township. This is from the spatial pattern of groundwater arsenic occurrence with association with bedrock geology in the greater Augusta, Maine. So this is a close-up of the image. The darker the image, the greater the concentration of arsenic. They associated arsenic with this formation, which is Silurian interbedded calcareous pellite and sandstone and limestone. So that is mainly the aquifer in the area is this fractured bedrock, this fractured siltstone, a sandstone. Here's a parcel map I got from the township of Manchester. In the northeast corner of the township is a sand and gravel aquifer that has a higher hydraulic conductivity value. I also used this map to delineate where the large well fields where I was going to use Visual AEM's leakage feature to model. So from this is I don't know if you can read that. It says community residential. So this is where it's really built up. Manchester does not receive water from the greater Augusta Water District. Mainly, so my next slide. Mainly, it comes from private wells, such as this image from my field trip in the area. Here's an image of Cobblesconny Lake. It's beautiful up there. It's gorgeous. Here is a map of well yields. The larger and darker the color, the better the well will produce. But I got this from USGS, and I was using this really to kind of map out the regions that I was going to use that leakage feature. Here's my conceptual model. Again, I was really concerned about the capture zone of these well fields. Basically, I varied the precipitation. I increased the precipitation rate or the recharge rate into the aquifer, and I wanted to see if the well fields grew or shrank. Will the public be exposed to more water coming from the west? From this image, there's some really bad stuff here. Basically, you can see from here, this is the Cobblesconny Lake. So that's this area here. This main road across, which a lot of communities are built on main roads, and Augusta right here is the state capital. So there's a a large amount of the population density here is greatest for the township, and that kind of goes across just like that. So I was able to use these two to model the well fields, and also the concentrations. I assume that if water was going to be coming up from the south in this region and hit the leakage areas that in my model, or from the west into those leakage areas, that I assume that the water would be of worse quality than it is currently. So obviously surface water bodies were a big part. This is lake region. I assume that the lakes were in direct connection with the groundwater. In doing that, I assume that the elevation of these lakes is the elevation of the groundwater in this region. Same thing with the streams and rivers that I put in there. And really, you know, it was kind of like, where is the water going to move when I change these recharge rates? And you know, as you saw, the private well is a huge feature for my model. So here's the regional model. This is from Mexicali Blues. It's really cool shop in Portland. Just again, you know, we're in the southern region of Maine. Here's an overview from Google Maps. This is what I used for or Google Earth. This is what I used for my regional model. I came out as the professor did in class at 200,000 feet by 200,000 feet. I centered Manchester at 0, 0, and I just kind of used the ruler to measure out distances. I think I did a fairly good job. There's a lot of lakes in the region. This area is the Belgrade Lakes region, if you're familiar with it. And you know, this is Kapuscani Lake. These images are wells that I did know the flow rate of. Again, there was you know, there was a greenhouse, a pizza shop, a daycare. That information I got from USGS. Here I modeled the aquifer with a lower conductivity value, and these smaller blue boxes are the leakage rates that I modeled as the well fields for the community. This here is the Kennebec River and the Androscoggin. So for my local results on the left, this is without any change in recharge. This is my model of the area. The precipitation I found for this area was 41.5 inches per year. I assume 10% of that was going directly to recharge. So this is with 4.15 inches of recharge per year. The image in the middle is I wanted to simulate climate change. You know, there's a lot of different predictions on what will happen, but basically more intense storms, more precipitation, more drought too. So for this model, I doubled the precipitation, yearly precipitation, from 41.5 to 83, so 83 inches. And instead of taking 10% of recharge, I used 30%. I really wanted to see something change here. You know, I really wanted to you know, see a difference in the head gradients, right? And to the right, this is I simulated a drought, so 0 recharge. As you can see, you know, so I ran the models, got the head contours. All the head contours looked very similar, and then I used the quick track function to try and see what is this capture zone for these different areas of the leakage. And they all look very similar. It doesn't look like it changed. And so in thinking about this, why? How come it didn't change? Why didn't it change? Well, I was looking for a change in really the head gradient, not the head. So, you know, I placed the same recharge over an entire area. The head levels did increase, but they increased at the same rate. You know, I really wanted to see a change in the gradient, a change in the groundwater flow, and I didn't get it because it was such an uniform recharge. Now, if I varied the recharge rate, I'm sure it would have changed a bit. But basically, for my model, I'm concluding that climate change won't impact the well fields, and thus won't really impact the public. A greater amount of public will not be exposed to worse drinking water. But still, 54.6% of Manchester residents, that's their population was about 2,500, say about over half, so 1,200 people, say about three, 2.5, 3 people per household. It's like 400 houses that are in, they're at risk of, you know, of this. And so this is really, we trying to avoid this. I didn't know about this issue here in Maine. I've only been up here for 2 years, but I know people that live in the area around Augusta, and it's an issue that people don't really know about. So, a lot of tourism in the area, a lot of summer camps. People rent houses off of like Craigslist and go fishing for the week, and it's something you don't ask is, well, how is the water quality, right? I mean, who would bother to check that? So you really, I'm planning on contacting some of the property owners in the area to see if they have tested their well water and if they need help installing a filtration system. I've my background is environmental consulting. I have a degree in environmental engineering, so this is kind of right up my alley of what I do, and how I can kind of turn this information into a way of both helping the public and a way of supporting myself. So that's it. Thank you. I hope I didn't go over too far. All right.